Hey guys, welcome back. Mr. Marone here. Welcome into lesson 8.2's video on trigonometric ratios. So trigonometry is an interesting topic because we use it in geometry with right triangles specifically, and then there's a whole nother branch of trigonometry within algebra and calculus, and you'll see that over the course of your math career. For our purpose, we're going to focus on right triangle trigonometry, only things that happen in right triangles. And the big thing you need to do before we even get started is make sure that your calculator is in degree mode. So there are two different types of ways to calculate angles in a triangle. There's degrees, which we've been using all year, and then there's another measure called radians, which we're not going to deal with so much. I want you guys to be in degree mode. So in your calculator, you're going to click the mode button, and then in that menu, when you look down the list, the third one down has the option of radian and degrees. Make sure that this one is filled in, that degrees is filled in. Otherwise, you're going to get all sorts of weird answers as you work through it. So just keep that in mind. So trigonometry is a branch of math that deals with the relationship between sides and angles and triangles, as you guys see there. That's the type we're going to focus on. And we have three ratios, just like we dealt with in similarity, that we're going to come back to. These trigonometric ratios are just the ratio of two side lengths of a triangle. So it's the comparison of one side to another within a given triangle. And there's three of them. There's the sine ratio, the cosine ratio, and the tangent ratio. On your calculator, they're abbreviated using the first three letters. So sine, they drop the E and it's just S-I-N. Cosine is C-O-S, and tangent is T-A-N. So comparing these values, we've got this thing called SOHCAHTOA. We use that as an abbreviation to help remember the ratios. The sine ratio is the comparison of our opposite side over our hypotenuse. So whatever those values are. Okay? The cosine ratio is the comparison of our adjacent side over our hypotenuse. And then our tangent ratio is the comparison of our opposite side over our adjacent side. So if you notice, just the leading letter of each of these, you've got your sine, opposite over hypotenuse for so, cosine adjacent over hypotenuse for ca, and tangent opposite over adjacent for toa. That's where that SOHCAHTOA comes from. There was a big long story about it that we were given as kids, but we're going to spare you those details. Now, you're going to see this funny little sign in each of these ratios, and it's the Greek letter theta. Okay, and it's just a reference that we use instead of using x. If you actually look at the x button on your calculator, it's an x, then a t, and then the third symbol is a theta. So it's just the way we reference angles. And if you see in the notes here, it's our reference angle, and it's always going to be acute. It's never going to be a right angle. So we can't ever do the sine, cosine, or tangent of angle B in our example picture here. We can't do anything from the right angle. So the hypotenuse is always the hypotenuse. It can't ever be considered opposite or adjacent. And all of these types of sides, the opposite side, the adjacent side, are all determined on the angle, on the reference angle and where it is in your picture. So if we look closely at this first example here, they ask which side is opposite angle B. Well, angle B is where our theta would go. And then opposite is directly across from angle B. So if I were to draw an arrow across, that would be my opposite side, and I'm going to label it OPP. The adjacent side is the side next to the reference angle that's not the hypotenuse. So the order that I always label in is I've got my opposite side straight across from the reference angle, then I label my hypotenuse, which is always across from the right angle. And then the last side, what's left over, is the adjacent side. So the side adjacent to angle B here is side A. And then they want us to find the value of each trigonometric ratio. So basically what they're asking for is for us in these first three, or all three of them, they want us to go from angle A, which is up here. So if I put my reference angle there, straight across from that, this is my opposite side. Straight across from my right angle is my hypotenuse, and then straight, the only one that's left is the adjacent side. Knowing that, our sine is going to be our opposite side A over our hypotenuse C. If I'm doing cosine, that's my adjacent side B over my hypotenuse of C. And then my tangent side is my opposite side A over my adjacent side B. That's really all there is to this. So when we get ready to add in some numbers, it's the same process. There's going to be 4 parts to every one of these equations. You've got your trig ratio, your reference angle, and then the 2 sides that create that ratio. And each time they're going to give you 3 of those 4 pieces of information, and you have to find the missing one. The only one you'll never have to find is the ratio, because of like which one you're using, sine, cosine, or tangent, because they'll tell you based on the sides that they give you. So let's take a look at some examples here. So in the first kind, I want to find the value of each trig ratio. So if I'm looking at this, they wanted all 3 are from F. So F is my reference angle. The first thing I'm going to do is label the sides. So here's my opposite side, here's my hypotenuse, and here's my adjacent side, all based on where the reference angle is. Now, sine of F, we said we had sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and then tangent was opposite over adjacent, SOHCAHTOA. So the sine of F is my opposite side 6 over my hypotenuse 10, which simplifies to 3 over 5. For cosine of F, it's my adjacent side 8 over my hypotenuse 10, or 4 out of 5. And then my tangent of F is my opposite side 6 over my adjacent side 8, which is equal to 3/4. So setting up these ratios are just like what you're about to do in the problems given. So you've got 4 examples here. In each one, your steps are going to be the same. Your first step is going to be label it. Then your second step will be to determine which ratio, and then you're going to solve. That's going to be the same for every one of these problems. So if I'm looking at example 5, this first one, my reference angle is right here. That tells me straight across from it is my opposite side, straight across from my right angle is my hypotenuse, and then I've got my adjacent side. Now, I tend to circle the word or the abbreviation and the information given. So they gave me my opposite side, and they gave me my hypotenuse. The only ratio that uses the opposite side and the hypotenuse is the sine ratio. So it's going to be the sine of my reference angle, 28 degrees, equals my opposite side x over my hypotenuse of 15. Now, if you wanted to, you could plug sine of 28 into your calculator. Sine of 28 is 0.46947, and then it continues. So it's just a number. It functions the exact same way. If you wanted to abbreviate that, we do 4 decimal places. You could then just solve it having a decimal in there. But just remember that sine of 28 is attached. We can't separate them, and it stays together, and it is just a number. So if I wanted to solve this problem for x, in order to get x on its own, I have to multiply both sides by 15. So I've got 15 times the sine of 28 equal to x. At this point, just go to your calculator. It's literally one step of algebra. So 15 sine of 28 is going to end up giving me 7.04. And that's my final answer. That's it. There's really no more to this process than that. I want you guys to try 6, 7, and 8. So remember, you're labeling. You're then determining which ratio, and then you're solving. And then when you come back in, all 3 of them will be solved for you. Okay, welcome back in. So I solved example 6, and I wanted to just step through 7 and 8. I realized that I jumped the gun there, letting you try to do those without first explaining it. So looking at example 6, I labeled, and I had information at adjacent and hypotenuse. The only ratio that uses adjacent and hypotenuse is cosine. So I set up my cosine of 68 equals my adjacent side over my hypotenuse, and then I multiplied both sides by 14. I multiplied by the denominator, just like I did in the first one. And getting to 14 cosine 68, I just went to the calculator and got 5.24. So for 7 and 8, things are a little different. I followed my process. I labeled. I had adjacent and opposite, so the only option I had was my tangent ratio. And when I set it up, I had tangent of 20 equals 16 over x. And if you're looking across the screen, you can see the same thing happened for example 8. So you're probably asking, what do I do? What mathematically can I do here? So if we look closely, we're going to do the same process. I'm going to get rid of the fraction by multiplying by the denominator. So I'm going to multiply both sides by x. So I have x times the tangent of 20 equals 16. And now, just using algebra to get x on its own, I'm going to divide both sides by tangent of 20. Remember, that's just a number. And so I have x equals 16 over tangent of 20. And if you look at what happened, I started with tangent of 20 on the left and x in the denominator of my fraction, and I ended with them switched. So the nice part is you can just swap them if x is on the bottom. It's a little shortcut there. And then at this point, it's the same thing. You go straight to the calculator. You do 16 divided by the tangent of 20 degrees, and you end up with x equaling 43.96. We usually go to 2 decimal places here. So now that you've seen that process, you can do the algebra like I did, or you can use just the swap and solve for example 8. Go ahead and try that right now. All right, welcome back in. So I took the shortcut method, no sense of doing extra work. We're lazy mathematicians. And I swapped cosine of 47 and x. And when we swap them, we have 19 over the cosine of 47, and you just go to the calculator. And when you went to the calculator for that, you have 27.86 as your final answer. So these are tricky, mainly because it's something like you've never seen before. The math is not hard. If you notice, in all 4 of these problems, I used a grand total of 2 steps of algebra at most before I went to the calculator. Most of them were 1 step. The thing is that they're just brand new. So make sure to try some of the practice problems, ask as many questions as you could possibly come up with in class, and I will answer them when you get here. All right, guys, have a great night. Bye-bye.